Hey kiddos, we got one test today called the alternating series test, which I think you're just going to love because you're going to know when to use it because it's called the alternating series test, which means it's for alternating series. So we're going to add to our sheet first and then go work 2 questions. Some notes. This one's only for alternating series. And I'll show you what those look like when we get into notes. And then this isn't going to make a lot of sense until I show you what it is, but I'm going to write ignore the alternator. All right, so alternating series test has 2 parts. So if you're trying to prove convergence and you have an alternating series, first thing you do is you take the limit of a sub n as n goes to infinity and you get 0. Second thing you do is you have to prove your terms are decreasing. And there's a couple ways to do that, but the easiest and the most straightforward is to take a generic term. Don't plug in. Some of you were talking about plugging in the other day. Don't plug in. You got to take a generic term and prove that it's less than the term that came before it. So the nth plus 1 term has to be less than the nth term. To prove diverge, if either condition fails. So if you take a limit and don't get 0, you're done. Or you take a limit and you get 0, but then you can't prove that the terms are decreasing, you're done. All right, so let's go work some two of them. So there's a lot of reasons you're going to like this test. Probably the biggest one is you're going to know when to use it, because one of the challenges that you're going to face is trying to figure out when to use which test and which test makes the most sense. So let's talk about what an alternating series looks like. Alternating series have these things that I lovingly call alternators. They almost always look like this, or like this, or like this. And that exponent, like they're exponential. It's -1 to an n, and it could be a couple different versions of that. And then there's something else. So for example, the first one we're going to do is this series. I'm going to make it +1 up here. That series. So if you're not sure if a series is alternating or not, because sometimes they're tricky, the only way to be alternating is if you go positive, negative, positive, negative. You can't go positive, negative, negative, positive. Like even if it has a pattern, it has to switch signs every term. It could start negative and that's still okay. But it's got to be back and forth every time. All right, so let's list terms of this series. So the first term of this series is going to end up being positive because I'm going to have -1 squared. The second term of the series is going to be negative, and then positive, and then negative. Do you know this series? It's called the alternating harmonic series. So do you see it in there? I mean, it's not very well hidden. We could write it like this if you'd like, but it's the harmonic series with an alternator on the front. So it's called the alternating harmonic series. Every series can become an alternating series if you just throw an alternator in the front. So let's see if this one converges or diverges. First thing we do is we take a limit as n goes to infinity. So here's what I mean by ignore the alternator. All of the work I do inside of proving this does not include the alternator. I'm just going to use this 1 over n. Oh, I get 0. Great. Second thing I do is I have to prove my terms are decreasing. So I'm going to take the n plus 1 term and show that that's less than the nth term. A really quick Chrissy Cross applesauce is going to do that for me. Therefore, the series converges. The end. That's alternating series test. I wonder if this was surprising to you, because we know the harmonic series diverges. But if we put an alternator on it, now it converges. That's special. So if you have a positive term series that diverges, and then you've put an alternator on it, the same series, just with an alternator, and now it converges, that is called being, put those two together, it's called being conditionally convergent. And we are going to spend a whole day talking about that Tuesday, Wednesday, sometime next week. Conditionally convergent. Okay, let's do one more. What about this series? Okay, so I know it's alternating because I can see the alternator. Now all the work I do is going to ignore the alternator, which feels weird. So we take the limit, we go to infinity. I'm just using 3n over 4n minus 7. I've been taking these limits for weeks now. Look, common degree again. I get 3/4. Oh, that's not 0. Therefore, diverges. Now, why does it diverge? Like what test do we use? Alternating series test. It's very tempting to put diverges by nth term test because we took a limit and we didn't get 0, but we didn't take a limit of the whole thing, which is what nth term test would want us to do. So don't do that. All right, let me know if you need anything.